Hello everyone. Discussing about the research methodology in science, we are discussing the research design. Now the research design is the first aspect of research methodology, and in fact it involves the entire research methodology to be planned, structured and strategized so that we can go through a research process and construct certain kind of or generate certain kind of scientific knowledge, the solution to our problem that we started with. So the research process, if we just look at that, is basically like I show that the empirical research process, it starts with the observation or certain kind of a intellectual curiosity. So it's not just you are curious about that, okay, this is happening or why this is happening, but also about the reason behind it or scientific explanation behind such kind of curiosities. So you start with the observation and the curiosity, then you do a literature survey, you execute the you lay down the research methods, then you execute those plans, you find certain findings and results, you discuss those results, you infer those results, you evaluate those results for the reliability and validity, you conclude something out of it, and then if you find, you again refine that research. So in this again a chart I show you that basically you start with the observation part, then you lay down a hypothesis. So first you become curious about something, you lay down a certain hypothesis, then you investigate that hypothesis and you find, you have the results and findings, and then you will probably reject the hypothesis or accept the hypothesis. If you accept the hypothesis, you go on reporting that, as I said, sharing the knowledge. If you reject the hypothesis, you think again and you go back to the strategy of modifying your hypothesis or doing the theoretical modelings and theoretical methods employing again, and you go through the same process. So this is the scientific method that is basically involved in it. Now looking at the characteristics of a research design, now the four important characteristics of the research design are basically the validity, the reliability, the generalization as we say, and then again the authenticity which is there. So neutrality which is there. So neutrality, when we say, when we talked about the different aspects of research design, we said that it reduces the bias and the errors. So neutrality is a very important point. If you randomly start with doing something, it is tend to have, if you have not strategically thought about what different components that you need to keep in your research, like as I said, if you have not kept enough controls of an experiment, then basically your results are going to be biased or error prone. So the characteristic of a good research design is that it has to be neutral. So as far as neutral it has to be there. Then there has to be a reliability, or there can be a replicability. The whatever research design you have incorporated, it should have a strong authentic source of methods or even modeling, whatever you are doing, it needs to have an authentic source. You are not just doing it randomly or hypothesizing certain randomly. It has to be governed by certain key parameters, and as we will see that how these hypotheses are laid down, what are the different kind of parameters that we incorporate in a subsequent session. But the idea is that it has to be reliable. It has to be whatever components are there to execute this research design come from an authenticated source. So it is not randomly that you are designing, randomly. Even if it is something innovative, then that innovative also has to have a backup of a knowledge source. See, creation of knowledge or generation of knowledge is not based on vague or random hypothesis that you have started from. Obviously, you need to have a strong knowledge base, and then you have to have the authentic methods and resources that you employ. You can generate a new method as well, but for that new method too, there has to be a strong knowledge base that it comes from. So more it is from the reliable sources, more there will be reliability in the research design. Validity we will discuss because it is the most important aspect, and if in fact you can test a research design based upon the validity of the conclusion, and that we will discuss again what this validity constitute for. And of course there is a generalization aspect. When you are creating a research design, in fact for validity as well, there has to be a the research design is not just specific to a very small problems as such. So it has to be generalized in the sense that everything that is explaining that phenomena or a particular behavior can be explained by that kind of a, or can be done by that kind of a research design. So it is not just a way that you have found out to solve just one particular problem, but in fact you have generalized it and you have employed different methods that can be involved into it. So these are the certain characteristics of a research design. As I said, we have to look and understand the quality of a research design. So how do we say that a research design is good? Those were the 4 characteristics. Now out of those 4 characteristics, validity becomes very important, and it can be tested. The quality of the research design can be tested by the study's conclusion validity. This is one aspect of it. So what is conclusion validity? We discussed in a different context when we were discussing about the general characteristics of the research methodology in our previous session, but I discuss it here again because this is a very important parameter to check or test the quality of a research design. So looking at the conclusion validity, it refers to the extent of researchers' ability to draw accurate conclusions from the research. That is the degree of a study's internal validity as well as the external validity. So whatever results and findings you have got, when you infer something from that and when you conclude something from that, then that validity of that conclusion based upon checking the parameters of internal and external validity will tell you the quality of a research design. And after that you go for the refinement. So you go for the refinement of the research design and undergo the process again if you have not got a best solution for the problem or the hypothesis is not accepted. So what do you mean by this internal validity? Internal validity is the correctness of the conclusions regarding the relationships among the variables examined. Now what are these variables that are examined? So quality of a research design is whether the research findings accurately reflect how the research variables are really connected to each other. Now I will take a pause here in the research design and explain certain key terms. These key terms which are like, what are variables? When I say research variables, what are these research variables I am talking about? In the conclusion, we try to connect these research variables. You know, this statement at least gives you this idea that to explain any research finding or to accurately say that this is the research finding, that finding should reflect the connectivity between the research variables. So we start our research by having these research variables, and then through the process of research we try to connect these research variables to each other. And when we get certain findings or we conclude something, then the accuracy of our design depends upon how well we are able to connect the research variables that we started with. So let's understand these research variables at this point of time. What is a variable? So variable is a concept that can take on various quantitative values. For example, weight, height. You know, if I take, or if I am going into studying something, and if I take, for example, the weight of the students in a particular class, then that weight is a variable, because the weight value can be changed. You know, if there are 60 students, then there will be different kinds of values that can be attributed to the concept of the weight. So that is the variable. Now, there are two key types of variables which are involved in the research process. One is an independent variable and another is a dependent variable. As the name suggests, independent variable is an experiment, in an experiment is considered to stand on its own. So, it is an independent variable. It affects the dependent variables, but by itself is not affected by anything. So, that is the independent variable. We basically try to find out, or we ascertain these variables to the when we are laying down the hypothesis, or when we are executing the methods to find out the solution to that, or whether to accept or reject that hypothesis or solution to that problem, we lay down these parameters. So, we assign the independent variable to certain key concepts, the concepts which can stand alone, and then we also execute these dependent variables which are affected by the values of the independent variables. So, dependent variable, I will take up the example and it will be more, it will be clearer to you. A dependent variable is a variable that is tested. It is a dependent in some way on the variation of an independent variable. For example, if we want to explore whether the high concentrations of vehicle exhaust impact the incidence of asthma in children, then vehicle exhaust is the independent variable. In our study, you may say that vehicle exhaust will be dependent upon the type of the car, how old a car is, or what kind of a vehicle it is, how much it is running. So, you would say that this vehicle exhaust is not an independent variable, ma'am, as you say. But in our study, because our study is to explore whether the high concentrations of vehicle exhaust is impacting the incidence of asthma in children or not. So, vehicle exhaust in this particular study is an independent variable, while asthma is the dependent variable, because high concentration of vehicle exhaust. Now, what is the concentration? So, depending upon the differences in the values of the vehicle exhaust, which would be due to any of the factors, as I said, depending upon the type of vehicle, how old a vehicle is, or what kind of exhaust it is giving out, depending upon any of the factors, if the value of the vehicle exhaust changes, its impact on the incidence of asthma in children would change. So, asthma is the dependent variable, whereas vehicle exhaust is the independent variable. So, I hope you understand in here. It is when you are trying to design a research, a strategy of finding out this particular aspect, then there are many different factors that are involved. But first of all, we have to lay down that what is a dependent variable and what is an independent variable. Then comes the external validity. So, if we are able to connect whatever conclusion we are going, for example, we are doing this particular research only, we are exploring whether the high concentration of vehicle exhaust impact incidence of asthma in children, and if at the end of our findings we are going to conclude that the higher concentrations of vehicle exhaust does impact, or impact severely the incidence of asthma. Now, impact severely, this severely we can give a percentage. High concentrations we can give a percentage, that so and so is the high concentration, or how much is the percentage of impact, that will depend upon our findings. But if in the conclusion we do say that high concentration of vehicle exhaust severely impact incidence of asthma in our children, then that conclusion, the internal validity is that are we able to connect the two variables to each other well or not? Do you understand that? If we would have concluded that high concentration of vehicle exhaust impact children, for example, if we had just done this study and concluded that high concentration of vehicle exhaust impact children, we have not been able to connect the two variables with each other. It is impacting children, it might impact their behavior, it might impact their skin, it might impact the asthma, it might impact their eyesight, it might impact anything. So that we started with the hypothesis, or we started with the problem to explore whether the high concentration of vehicle exhaust impact incidence of asthma in children or not. So if in conclusion we are not able to connect these two things together, then the conclusion is not validated and it is not a good design. In a good design, I say, how do you conclude that it impacted children? Because you studied the children and you studied various parameters but did not study the asthma. You did not measure the asthma, but you measured various aspects that, because they become tired or they become playful, or whether their eyes are, they are tearful because of the vehicle exhaust or not. So you include these kind of parameters in your study, but you do not include their lung capacity or occurrence of the asthmatic attacks or anything of that sort. It is not a good research design, because that is not what your hypothesis was based on. That is not what you started to do research on. So it is not a very good design. Even if you say incidence of asthma, then in incidence of asthma you have not taken various parameters, because probably incidence of asthma you just correlated the concentration of exhaust to probably the asthmatic attack. So every children will not have an asthmatic attack, but they may have, their lung capacity would be differing, or there will be very many different kind of symptoms which is saying, aggravating, all these different kind of things. So I hope you get my idea that the dependent and independent variable that you started your research with needs to be connected very well. If this internal validity is there, then that is a good research design. Otherwise, you will have to think it over and keep it in that way. Another validity that comes into being is the external validity, which also governs the generalizability of the generalization, a key aspect of the research methodology, characteristic of the key research methodology that we talked about. So external validity is the generalizability of the findings to the intended appropriate population or setting. That is, whether the appropriate subjects were selected for conducting or not. As I said, your research was to find out the effect of higher concentration of vehicle exhaust on the incidence of asthma in children. But when you have created the research design, you did not take enough children. You probably study all the people in that particular area, where the proportion of children was very less. So whatever conclusion you are making, it is not validated. It is not related to the research that you were trying to do. So this is kind of an external validity. Moreover, you should have an appropriate, when I say intended appropriate population or setting. So when you are intended to find the incidence of asthma in children, your sample, the research on which you are doing is going to be the children. There has to be a sufficient sample size. You cannot look at just 2 children and generalize the fact that vehicle exhaust, higher concentration of vehicle exhaust does affect children, because you examined 100 people, but out of those only 10 were children. It is not a good research design. So you always have to think for that whether your findings can be generalized to the intended or appropriate population or setting. So whether the appropriate subjects were selected for conducting or not. So when you make a conclusion, the internal validity as well as the external validity is going to test the quality of a research design which is there. And in fact, when you lay down the predicted results and findings, you can also make your research design more robust yet flexible. When we talk about this external validity, then another variable that comes into being is what is called as a confounding variable or a confounder. So we talked about dependent and independent variable. I hope that is very clear to you. Another is the confounding variable or a confounder. What does that mean? It affects the relationship between the independent and the dependent variables, but it is not the part of your research. So, for example, in our only example, confounder would be the differential exposure to other factors that increase the respiratory issues like cigarette smoke or particulate matter from the factories. So, your idea is basically dealing with the vehicle exhaust, effect of higher concentration of vehicle exhaust, but the subjects that you are studying, they might be exposed to other factors as well. So, this is not what you are researching on, but it is affecting the relationship between the independent and dependent variables that you have laid down in your research. So, these confounding variables or confounders are also there, which is very important. Now, because it would be unethical to expose a randomized group of people to high levels of vehicle exhaust, a study comparing the two populations with differential exposure to vehicle exhaust would rely on a natural experiment or a situation in which this already occurs due to factors unrelated to the researchers. Now, this is a very, very important aspect that lays down the significance and importance of the confounding variable which is there. So, you know, if you are studying, for example, if you are studying the impact of a disease or if you are studying the impact of a vehicle exhaust, you will not have healthy children and you will expose them to higher concentration of vehicle exhaust to create, to conclude something, or to have a scientific knowledge of like whether the vehicle exhaust, it is very unethical to do that, to expose healthy children to higher concentration of vehicular exhaust. But then how do we conduct that study? So, that study is designed in a manner to include this confounding variable. Obviously, you will try to have a control on this confounding variable, but you will use the subjects which might have been asthmatic due to exposure to other kind of sources, such as for example, the particulate matter from factories, or as I said about the different kind of smoking cigarettes, etc. So, that kind of things also, or variables also, you have to keep in your mind. In this natural experiment, a community living near higher concentration of car exhaust may also live near factories that pollute or have higher rates of smoking. So, choosing or subject selection becomes a very key aspect of your research design which is there. Now, how to achieve this internal and external validity? I hope I am clear about the checking the quality of a research design, which can be tested by ascertaining the validity of the conclusion, and in that validity we talked about the internal and the external validity. So, we understand that what is the internal and external validity, but how do you achieve that? You achieve that by effectively controlling three types of variances. Now, what are these three types of variances? First is the systematic variance. Systematic variance is the variance of the independent and dependent variable. So, that systematic variance is basically the variability which is intrinsic to the independent and the dependent variables. It is called as the systematic variance. Then the second would be the confounding variance. As I said, variability of the potential nuisances or extraneous or confounding variables. We need to control these variances. And the third is the error variances, the variances that is attributable to errors in measurement that is there. If we are able to reduce these three kinds of variances, we are able to achieve the internal and external validity for the conclusions, and therefore can generate a very good or qualitative research design which is there. Now, there is a max-min-con principle which is the guiding principle for effective control of variances. What is this max-min-con principle? That you maximize the systemic variance. So, you maximize the systematic variance, you minimize the error variance, and you control the variance of these nuisance, extraneous, exogenous or the confounding variables. How do you maximize the systematic variance? So, maximizing the systematic variance is by widening the range of values of research variables. So, you have to increase the range of the value of research variable. In the experiments where the researcher actually manipulate the independent variable and measures the impact on the dependent variable, one should properly manipulate, proper manipulation of experimental conditions to ensure the high variability in the independent variable. For example, when we were talking about the vehicular exhaust, higher concentration of vehicular exhaust. So, we need to keep a large range of the concentrations of vehicular exhaust. In the vehicular exhaust, we need to again keep a range so as to know about the vehicular exhaust from HVVs or from the light vehicles, from cars or from bikes. So, we need to keep a range of vehicles so as to have the good conclusion. So, we maximize this systematic variance. More is the variability in the independent variable, more will be, we will be able to ascertain the value of the dependent variability on the dependent variable on that independent variable. So, whatever range we are choosing, so when we are doing the experiments, we can properly manipulate it by using the different kind of experimental conditions to ensure this kind of a high variability in independent variable. In non-experimental studies, because as I said, there are certain population studies, community studies where we do not involve the experimental aspect or doing certain kind of experiments. Then in non-experimental studies where independent and dependent variables are measured simultaneously and the relationship between them are examined. Appropriate subject selection, selecting subjects that are sufficiently different with respect to the study's main variable. So, you avoid the range restriction. So, when it is not involving, when your experiment is involved, you choose the range in terms of the different conditions that you can employ in that experiment. But if it is a non-experimental study, then you choose various kind of independent and dependent variables and try to find out the correlation between them or the relationship between them. So, there should not be any range restriction, it should be as wide as possible. So, that becomes a maximizing the systematic variance. Minimizing the error variance is basically minimizing the part of variability in scores caused by error in measurements. So, the sources, what are the sources of this error variance? When you are using certain kind of instruments or equipments, they have an inherent error. So, these errors you have to account for and you have to minimize you have to look for the ways to minimize these error variances. What are the sources of these error variances? Poorly designed instruments. So, there are instrumentation errors which are there. Error arising from the study subjects. For example, response error. If you do a certain kind of a survey and if you choose certain study subjects where there is a responsive biasness, we will talk about that also, then the error will emanate. Then there are basically contextual factors that reduce a sound accurate measurement or instrument's capacity to measure the accurately. So, intrinsic error or how accurate, the limitations of the instruments or the limitations in the study subjects, the error emanating from that, these are the sources of error variances that arises. How to minimize these error variances? You increase the validity and reliability of measurement instruments and you measure variables under as ideal conditions as possible. So, you reduce these variables. First of all, you use those instruments, you use those equipment which are reliable or which have which have been validated to produce as perfect results as possible. So, increase that kind of confidence in the measurement instruments so that you can minimize the error variance, and moreover you can also measure the variables under as ideal conditions as possible to minimize this error variance. So, you maximize the systematic variance, you minimize the error variance, and we will continue with the controlling the confounding variables and different types of research design in our next session. Thank you.